Okay, so let's try to find what the inside function and the outside function is. Here, well, the most outside function is the natural log. Okay, and then in there we have a exponential function, which is 4 raised to a power, and inside of that we have natural exponential, and inside of that we have x squared. Okay, so this one actually isn't that bad. So let's work through it how we usually do it. The derivative of the natural log, remember, is 1 over x. And so here the derivative of natural log of all this stuff is just going to be 1 over all of that stuff. Okay, and then times the derivative of the inside, which is the black stuff. So the derivative of 4 raised to a power is itself, leaving the inside alone, times the natural log of 4. Okay, and then we go one level further and get the derivative of e to the x squared. So the derivative of e to the x squared is itself, leaving the inside alone, times the derivative of the inside, which is just 2x. And that's it. Okay, number 4 is quite difficult. Notice that this isn't our conventional exponential function. This, we have a function raised into another function. So we don't have a rule for that. We have a rule for when, for example, if this x right here was a constant, we can use the power rule. If this guy inside was a constant, we can use the rule for derivatives of exponential functions. These are both functions. You have a function being raised to another function. And so for this, the only way that we can solve this is by using logarithmic differentiation. Okay, so remember, the idea behind it is that you use the rules of logs to bring down the exponent. So like, for example, here we would get the natural log of both the left side and the right side. Okay, now when we do that, we're going to get the natural log of f of x is equal to, now we can use the third law of logarithms, which states that we can bring the power out in front, so we would have x times natural log of sine of 5x squared. And then what we do is we use implicit differentiation, so we can get the derivative of both the left side and the right side. Okay, so when we do that, well, here we have a slightly tricky situation. So here we have the natural log of a function, so here we have to use the chain rule. And so the outside function here in this case would be the natural log, and the inside function would be f of x. Now f of x is this our original function, but we're just going to leave it as f of x to keep the notation small. So we're going to use the same idea, but it's going to be a little bit more abstract. So bear with me here. So we have the derivative of natural log. Remember, the derivative of natural log is just 1 over x. So instead of x, we have 1 over f of x because you leave the inside alone. And then times the derivative of the inside. Okay, now the derivative of the inside, I'm just going to write it as f prime of x. Okay, so all we've done is use the chain rule, but it's a little bit abstract. So we have natural log. The derivative of natural log is 1 over the function times the derivative of the function, which we wrote as f prime of x. Okay, now on the right side, here we have a product, so we have to get the derivative. You have to use the product rule to get the derivative of the right side. And inside of here, we're going to have to use a chain rule and all kinds of weird stuff. So let's work this out. So the product rule says we're going to get the derivative of the first, which is just 1, times the second, leaving it alone. So natural log of sine of 5x squared. Okay, and then plus the first, leaving it alone, times the derivative of the second. Now, here the derivative of the second, we have to use the chain rule again. So here the most outside function is natural log. So the derivative of natural log is 1 over the inside, leaving it alone. So I'm going to have 1 over sine of 5x squared times, now I move one level further, so I'm going to get the derivative of sine of 5x squared. Well, the derivative of sine is just cosine, leaving the inside alone. And then last but not least, the derivative of the inside of sine, which is just 10x. Okay. And then the last step, see what I'm looking for this whole time is the derivative of f. Well, I have the derivative of f here. What I want to do is move f of x over. So I'm going to multiply both sides by f of x. So then what I have is that f prime of x is equal to, I'm just going to clean this up a little bit, natural log of sine of 5x squared plus, here I'm just going to combine this 10x and this x here, those combine to be 10x squared over sine of 5x squared times cosine of 5x squared, and all of this is being multiplied by f of x, but f of x is my original function, this guy right here, so I'm going to just rewrite the original function here. The original function, sine of 5x squared, all raised to the x, without the natural log, because the natural log isn't the original function. And that's it. That's my derivative.